I had a question about homework problem 4.3a, and in this problem there's a box that's being pulled across the floor with a tension force that's some angle above the horizontal, and we're told how far the box moves, and we want to figure out how much time that takes. So the process we need to do is first figure out the acceleration of the box using Newton's laws, and then use kinematics to solve for the time. So we'll use Newton's second law to find A, first of all, and then use kinematics to find the time. Okay, well, let's analyze this problem. To find the acceleration, we can do that with a free body diagram. There's our coordinate system and object of interest. We have gravity. We have a normal force. And this tension force happening at an angle. Let's look at that tension force and get the components. If you look at it as a right triangle, you can see that the x component is adjacent to that angle, so it gets cosine. And the y component is opposite, so it gets sine. Another question I saw a few times in this week's discussion was, is it always true that an x component will have cosine and a y component will have sine? The answer is no, that's not always true. It depends on where the angle is in the drawing. If this theta were over here in the triangle, then that sine and cosine would be flipped. Okay, so let's do Newton's second law now. And I hope it makes sense to you that we only need to do the x direction, because we're not asked any questions about the y direction. There's no friction involved, so doing the y direction is kind of pointless. There's only one force in the x direction. It's that x component of the tension. So A equals Tx over m, or T cosine theta over m. And you all have different numbers in your homework problem, so I didn't put any numbers, but you're given t, you're given theta, and you're given m. All right, so now the next part of this question, use kinematics to find time. Well, what the problem says is that the box starts from rest. So Vx initial is 0. The problem tells us how far the box goes. So we know delta x is given. Some value, depends on your problem. And we know the acceleration, because we just figured that out. We want to find time, So we got to choose the right kinematic equation to use, and go through your list of 4 kinematic equations. The first one, that doesn't help. Second one also doesn't help because we don't know V final. Third one, yeah, that one seems pretty good. That part's 0. And we can subtract x initial from both sides to get delta x. And finally, we can do a little bit of algebra to solve for t.